When we evaluate a limit at infinity, sometimes it isn't obvious right away what that limit is equal to because it creates what's called an indeterminate form. One indeterminate form that arises from a limit at infinity is when a function f of x is a rational function defined as p of x divided by q of x. And when you plug in that x is going to plus or minus infinity, you get some type of infinity divided by infinity. Another type of indeterminate form is when the function f of x is the difference of two functions, such as p of x minus q of x. For this one, when you plug in infinity or minus infinity, what you're going to get is some form of infinity minus infinity. We're going to look at both of these forms separately, and we're going to start by evaluating limits with the indeterminate form infinity divided by infinity. When you evaluate a limit that has the form infinity divided by infinity, what you're going to do is divide the numerator and denominator by the highest power of x in the denominator. Let's look at some examples so we can see exactly how this works. In these examples, we're asked to find the limit. In our first example, we're taking the limit of 4x minus 3 divided by 2x minus 1 as x goes to infinity. Whenever you evaluate a limit, the first thing that you want to do is substitute in what your value x is going to. So let's go ahead and let's do this. X is going to infinity, so we have 4 times infinity minus 3, all divided by 2 times infinity minus 1. 4 times infinity is going to be a lot bigger than minus 3, so I'm going to write that the top is equal to infinity. And then the same thing happens with the denominator. 2 times infinity is a lot bigger than minus 1, so we can write this as infinity. And we get the indeterminate form infinity divided by infinity. What we're going to do now is divide the numerator and the denominator by the highest power of x in the denominator. This power of x is right there. So we're just going to divide the top and bottom by x. This gives us the limit as x goes to infinity. We're going to take the top part and divide it by x. And then do the same thing for the bottom part. Now we'll go ahead and break it up into pieces. So we have the limit as x goes to infinity. 4x divided by x is just 4, and then we have a minus 3 over x. And in the denominator, we have 2x divided by x, so that's just going to be 2 minus 1 over x. Now we can go ahead and plug in that x is approaching infinity. So this is 4 minus 3 divided by infinity, all divided by 2 minus 1 over infinity. This term is going to go to 0, and this term is going to go to 0. So we're left with 4 divided by 2, which is 2. So 2 is the value of our limit. Let's now look at our second example. This one is a lot harder than the first one. We're going to begin just like we did with the first one, and we're going to substitute in that x is going to plus or minus infinity. This is equal to the square root of 2 plus or minus infinity squared plus 1, all divided by 5 times plus or minus infinity minus 3. Let's look at the numerator first. The biggest term is the first one, 2 times infinity squared. So let's just write this as the square root of infinity squared, all divided by 5 times plus or minus infinity minus 3. The minus 3 won't matter, so we can just write this as plus or minus infinity. So we end up with some form of infinity divided by infinity, which is an indeterminate form. Now what we're going to do is divide the numerator and the denominator by the highest power of x in the denominator, and that's just going to be x. This is equal to the limit as x goes to plus or minus infinity, the square root 2x squared plus 1 divided by x, all divided by 5x minus 3 divided by x. This is actually more complicated than it looks. We need to know how to divide a square root function by x. To figure out how to do this, let's look at the definition of the square root of x squared. You may or may not have seen this before. The square root of x squared is defined to be the absolute value of x, and we know absolute value of x is x when x is greater than or equal to 0, or minus x when x is less than 0. This tells us as x approaches positive infinity, the square root of x squared is going to equal x. And then as x goes to minus infinity, we're going to look at the other piece, and we can write down that the square root of x squared is equal to minus x. Now let's apply this to our limit. Notice that we have a different value as x goes to infinity and as x goes to minus infinity. This means that we're going to have to look at our limits separately. Our first limit is the limit as x goes to infinity, square root 2x squared plus 1, all divided by 5x minus 3. Now we're going to divide the top and bottom by x. So this is the limit. X goes to infinity, square root 2x squared plus 1. Here, we're going to divide by the square root of x squared because x is going to infinity. And then on the bottom, we're just going to divide by x. This gives us the limit as x goes to infinity of the square root. Pulling in x squared, we have 2x squared divided by x squared is just 2, and then we have a plus 1 over x squared. And in the denominator, 5x divided by x gives us 5 minus 3 divided by x. Now, as x goes to infinity, this piece and this piece are going to go to 0. So what we have left as an answer is the square root of 2 divided by 5. Let's go ahead and let's highlight that. Now we're going to look at the limit as we approach minus infinity. This is the square root 2x squared plus 1, all divided by 5x minus 3. Hang with me. I know my students, when I used to teach this in class, felt like this was one of the hardest problems they've done. Since x is going to minus infinity, looking over to the right, we can see from this right here that x is equal to minus square root of x squared. So that's what we're going to divide by. In the numerator, we have 2x squared plus 1, and we're going to divide by minus square root x squared. And then on the bottom, we're just going to divide by x. So we have 5x minus 3 divided by x. I'm going to go down here to the lower left. We're kind of running out of space. Let's rewrite this as the limit. X goes to minus infinity. Do you see this minus sign right there? We're going to take that out in front. So we have minus square root. Now we can take the x squared inside the other square root, and this becomes 2 plus 1 over x squared, just dividing everything. And then in the denominator, we have 5 minus 3 over x. As x goes to minus infinity, this term and this term are going to go to 0, and we're left with an answer of minus square root of 2, all divided by 5. This is an example where the limit as x gets really large is different than the limit as x gets really small. Let's now look at how to evaluate limits that have the indeterminate form infinity minus infinity. To evaluate these types of limits, what we're going to have to do is use algebraic techniques to simplify the limit. Those techniques can be factoring, getting a common denominator, multiplying by a conjugate. I actually have a video on all of those techniques if you need to review that. Let's now look at our examples. In these examples, we are going to find the limit. Let's look at our first one. The first thing we're going to do is plug in that x is going to infinity. So this is infinity squared minus infinity. And this is called the indeterminate form infinity minus infinity. What we're going to have to do now is look at our function, x squared minus x, and figure out how to simplify that. When I look at that function, I see that there is an x common to both terms. So let's start by factoring out an x. This becomes the limit as x goes to infinity, x times x minus 1. Now let's go ahead and let's plug in that x is going to infinity, and we have infinity times infinity minus 1. So that's just equal to infinity. And that's actually what our limit is equal to. This is an example of a limit that does not exist, but if you can say that the limit is infinity, that is better than just saying it doesn't exist. This just gives us a little bit more information about the behavior of the limit. Let's now look at our second example. Again, we're going to start by plugging in that x is going to infinity. So we have the square root of infinity to the fourth plus 6 times infinity squared minus infinity squared. This is equal to the square root of infinity to the fourth. We're going to ignore the 6 infinity squared because it's a lot smaller compared to the infinity to the fourth. And then we subtract infinity squared. But the square root of infinity to the fourth is like infinity squared. So this is really the indeterminate form infinity minus infinity. Now we have to figure out how to evaluate this. When I look at our function, notice that it has a square root and then it's subtracting something after the square root. That tells us that we should probably multiply by the conjugate. The conjugate of the square root of a minus b is the square root of a plus b. So that's what we're going to multiply by. This is equal to the limit as x goes to infinity, the square root x to the fourth plus 6x squared minus x squared, and we're going to multiply by the conjugate. So we have the square root x to the fourth plus 6x squared plus x squared. We're just changing the sign. Now, this is really important. We can't change the limit. So if we multiply by the conjugate, we also have to divide by that same thing. X to the fourth plus 6x squared plus x squared. Doing it this way, it's like multiplying by 1, and we don't change the problem. Now let's go ahead and let's multiply things out. Just to make it easier, I'm going to use the FOIL method. So we're going to multiply the first terms. That's both of the square roots, and they multiply out to be x to the fourth plus 6x squared. And now we're going to multiply the outer terms. That is the square root x to the fourth plus 6x squared times x squared. Now let's multiply the inner terms. I'm going to go ahead and put parentheses up here to make it easier. The inner term is minus x squared times the square root of x to the fourth plus 6x squared. And then finally our last terms, which is our x squared terms multiplied, which is minus x to the fourth. Now we're going to divide all of this by the square root x to the fourth plus 6x squared plus x squared. Now the nice thing about multiplying by a conjugate is that things cancel. Let's go ahead and let's see what cancels. Our x to the fourth is going to cancel. And then this term is going to cancel with this term. And we only have one term left on top. Let's go ahead and let's write that down. This is the limit as x goes to infinity, 6x squared, all divided by square root of x to the fourth plus 6x squared plus x squared. Now what we're going to do is we're going to have to plug in infinity again and see what we get. When we plug in infinity, on the top, we're going to get infinity, and on the bottom, we're going to get infinity. So now we have another indeterminate form, infinity divided by infinity. We just talked about this form, so we know exactly what to do. We are going to have to divide by the highest power of x in the denominator, and that's going to be x squared, which is the same thing as the square root of x to the fourth. So we're going to divide the top and the bottom by x squared. So we have the limit as x goes to infinity, 6x squared divided by x squared, all divided by the square root x to the fourth plus 6x squared. That all gets divided by x squared, and then we have an x squared that gets divided by x squared. Let's see what this is. On the top, our x squares are going to cancel, and we're just going to have a 6. In the denominator, we're going to bring in the x squared as an x to the fourth. So this is x to the fourth plus 6x squared, all divided by x to the fourth. And then we have a plus 1. Hang with me, we're almost done. We have one more step to do. On the top, we have a 6. Now we're going to divide out this x to the fourth. This is going to give us a 1 plus 6 over x squared plus 1. Now we can go ahead and plug in. X is going to go to infinity. So this term is going to go to 0, and we have a 6 all divided by the square root of 1 plus 1. So this is 6 divided by 2, which is equal to 3. So our limit is equal to 3. I've graphed this function down here at the bottom so that you can see that as x gets really large or really small, our function is going to go to the value of 3.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.